Can I start now?
Yes, you can.
And good morning, everyone. My name is Debowale Adeyinka Hassan. I'll be presenting to you about microservice architecture. This topic is not only interesting, but also an important one because it's the approach we take for development at Bencom. This presentation will cover the definition of microservices, what microservice architecture is used for, the key benefits of microservices architecture, how do you get started with microservice architecture, how can we use API gateway to solve some of the challenges in dependency, then how do we scale microservices? Microservice architecture, often shortened as microservices, is used to refer to an architectural style for developing applications in which large applications are separated into smaller independent parts, with each part having its own realm of responsibility. As opposed to the monolithic architecture of software development, the microservice architecture involves the breaking down of business capability into smaller units so that each independent unit can scale as needs be. What is microservice architecture used for? It is used to break up monolithic application into smaller components, but they have different approaches. We can employ microservice architecture for website migration, to serve media content, and when you need to do a lot of transaction and hello, can anyone hear me? Hello?
Yes, I can hear you now.
Okay, all right. So the key benefit of microservice architecture, microservices can be built by one or small teams from the beginning, separated by services boundary, and it makes it easier to scale up the development effort if need be. Each services can be deployed independent of each other, and hence it makes it easy to identify all services and scale them independent of all application. It also offers improved fault isolation in the sense that a failure to a unit or a part of the independently coupled or loosely coupled unit will not mean that there's a total system collapse, but other units can function independent of the failure of one of the system. It also makes it easier to choose the technology stack which is best suited for the required functionality. For example, you might want to choose a different programming language to serve a different functionality in your application development, or a different database that suits the need of your development. Then how do we get started with microservice architecture? This will explain what to expect when you decide to use the microservice architecture as opposed to the monolithic design. To start with, you have to decompose your business services. And this is one of the ways to make our job easier. It could be to define the services corresponding to business capability. And by way of definition, a business capability is something a business does in order to provide value to its end user. For example, an e-commerce solution or a website can be divided into subunits so that each of the independent units will function independent of the others. You can divide it into sections such as cataloging, having a different microservice for shopping cart, a different one for discount, and ordering, so that we can develop each of one of them independent of the other. Once you are able to decompose your business into units, then the next thing is to design the individual services carefully. Now, decentralizing things. This technique involves using internal open source model. By using this approach, developers who need to change in the service can check out the code, work on the feature, and submit a pull request himself instead of waiting for the service owner to pick up and work on needed changes. And for this model to work properly, there's a need for proper technical documentation, which is needed to set up instruction and guidance for each service so that it's easy for anyone to pick up and work on the service. No wonder why the concept of documentation is being emphasized here at Bincom. So it's a very important tool to make your microservices function properly so that anyone in the organization can pick up a task worked on by a different developer and work on it independent of the previous developer. Then another hidden advantage of this approach is that it keeps developer laser focused on writing high quality code so that they know that because they know that others will be looking at it. So when you know others will be looking at your code in form of review, it keeps you focused so that you can write a high quality code. Then how do we build and deploy? After deciding on the service boundary of each small services, they can be deployed by one or small teams using the technologies which are best suited for each purposes. For example, you can choose to build a user service in Java with a MySQL database and a project documentation service with Scala or Spark. Then after building your solution, the next thing is to move into production. And how do you deploy? Once deployed, continuous integration and continuous development pipeline can be set up with any of the available CI servers to run the automated test cases and to deploy this service independent to different environments. Once your code is in production, you have to constantly make changes to existing microservice API. And to do this, you first have to employ versioning system when changes is required to your API. So you first version your API, then when changes are required for the API, deploy the new version of the API while still keeping the first version up. So you don't just phase out the previous implementation you have in your application. You do this gradually by deploying a newer version and phasing out the previous version. The dependent services can then be upgraded at their own pace to use the new version. Once all of the dependent services are migrated to use the new version of the changed microservice, it can be brought down. Then while you employ the microservice architecture, you have to ensure that there are standards of doing things. So because when there are multiple teams taking care of different services independently, it is best to introduce some standard and best practices. For example, for error handling, and it might be expected because as your service keeps growing, there's complexity attached to each microservice unit, and it becomes difficult to manage when you don't have a standard for managing something like errors in your application. Then you have to cater for service dependency. In a microservice architecture, over time, each service starts depending on one or more services. This can introduce more problems as the services grow. For example, The number of service instances and their location might change dynamically. Also, the protocols and the format in which data is shared might vary from service to service. Then, how do we employ API gateway to solve the challenges of dependency? API gateway are vital for communication in a distributed architecture, as they can create the main layer of abstraction between microservices and the outside client. The API gateway will handle a large amount of communication and administrative role that typically occur within a monolithic application, allowing the microservices to remain lightweight. They can also authenticate, cache and manage requests, as well as monitor messaging and perform load balancing as necessary. So when you think of using the microservice approach, you should also think of a way to manage or handle failure. And this is usually best done while you design your solution. There are two most used options to use the bulk head or the circuit breaker. The bulk head pattern isolates elements of an application into pool so that if one fails, the other will continue to function. And this is one of the benefits of microservice architecture. When one of the units fails, then it doesn't mean that all other units should fail as well. So because they work independent of the other. Then you can also devise the circuit breaker pattern to protect function call in the circuit breaker object, which monitors for failure. For example, when a piece of your code fails over time, you can decide to return an error, which in turn protects your system. Then this concept of microservice scaling is very important because it's actually what defines and make your applications scale as an enterprise. There are three major types of application scaling. You can have the x-axis scaling, the y-axis scaling, and the z-axis. As opposed to the monolithic system of application development, which doesn't have a well-defined or structured subunit for the Hello?
Hello, sir. We lost you for some time, but I think you're back.
Okay, all right. So the concept of scaling is actually part of what defines the microservice architecture. As opposed to the monolithic type of development, the microservice architecture can be scaled in three different ways. You can decide to Hello?
Yes, sir.
I'm sorry, I don't know if you get what, if I'm still on.
You're on, but I think there's just a brief network lagging behind.
All right. So as I've been explaining, the microservice architecture can scale in three folds, depending on the business need. For the x-axis scaling, it is also called the horizontal scaling. In this procedure, the entire application is subdivided into different horizontal parts. This might involve creating more containers or further dividing your application into subunits. This is made possible because of the system of development employed by the microservice architecture, in which each of the microservices has been broken down to work independent of the other. So when you decide to scale according to the business need, you can further break down your business capability into further microservice units. But this is not made possible by the monolithic system of development, because you only have your application as a whole. But when you want to scale your monolithic application, that's when the y-axis scaling is being employed. This is also called the vertical scaling, and it includes any resource level scaling. It might involve you increasing your disk space or trying to increase the resources used by each of the microservice units. Then there's something we call the x-axis scaling, which offers scaling through partitioning via business parameter. It allows the organization to serve premium customer or special requests or geodiversity in the dedicated cluster or server. It also can be infinitely scaled based on the business parameters. Now that we have covered what a microservice architecture is, why wouldn't want to deploy a microservice architecture and thought on getting started? I would like to offer a piece of advice. Start small. When you start, when your application is not, when it's this small, it makes it easier for you to have a well-defined subunits in your application, and you can scale as the business need. So I wish, hello?
You're still on.
Okay, right.
Yeah.
So I wish the best of success as you travel down this exciting microservice architecture path. Thank you for the audience.